A core goal of social science is the production of knowledge about the social world. In other words, sociologists are in the business of explaining society. How does society work? What are the processes and forces that influence human organization, and how do these forces interact? You might see from the way that I have phrased this set of questions that a scientific approach to studying society seems like the best bet we have for getting answers, for explaining society. After all, that's what the word science means. Science comes from the Latin scientia, or knowledge. But within the field of sociology, there's actually some strong disagreements over how to best explain society. Some deny the utility of science altogether. Those who take this view may, for example, characterize science as a power structure rather than a type of knowledge or set of strategies for exploring the world. From this view, science itself is a thing to be explained and cannot help us understand society. A different viewpoint holds that science is a useful means for understanding the non-social world, but the social world is so different that it either cannot be explained by science, or the type of science that can be used to explain the social world is far more limited than that of natural science. These two views appear to be motivated by a belief that the social world is fundamentally different from the natural world, to the point where scientific explanations are not really feasible when it comes to questions about society. From this view, a researcher might argue that studying molecules is just so different when compared to studying societies that there's no generalized approach to learning or explaining that could include both activities. Or they might argue that because humans can change and react to new information, only very imprecise scientific knowledge can be gleaned from the study of society. Others, including myself and many of the researchers we will learn about in this class, take the view that the character of science really doesn't change just because we stop studying molecules and start studying humans. While our objects of study and methods may differ, the underlying approach of generating useful knowledge about the world is much the same. That's true whether we're studying a strand of DNA, an entire person, or a whole society. Because there are a variety of viewpoints on science and how science relates to the study of society, what a sociologist means when they use the term theory really depends on the viewpoint that they take. In this class, we will take the view that science provides a useful means to explain the social world, and that the enterprise of science works just as well on people and societies as it does on atoms and molecules. If this were a theory class, we would dive deeper into the differing perspectives, exploring their arguments, and examining how each position has historically produced sociological knowledge. But if we did that here, we would never get to social psychology, and this is a social psychology course. Since most of the theorists in social psych take a scientific position in their work, we will take this view as well. But I do want you to understand that there are those who disagree with this perspective. So, for this class, the point of theories is to develop scientific knowledge about a specific area of interest. In our case, we're interested in scientific theories that help us understand how individuals relate to societies. Okay, with a scientific orientation as our starting point, we must now ask, what do scientific explanations of the social world look like? Well, the philosophy of science is filled with people arguing about what exactly scientific knowledge looks like, but here's a brief outline of some of the characteristics that I think are important. When we say that scientific knowledge is testable, we mean that some claim being made can be shown to be wrong. Not every aspect of a theory will be testable, but theories should make testable claims. If they can't do that, then they're not really producing scientific knowledge. Scientific knowledge needs to be testable because we want to represent the empirical world. The models that we create need to be tested against the real world to make sure they're actually describing the world as it exists. So what do untestable theories look like? Well, in social science, there has historically been two common forms of untestable theory. First, there are theories that make testable claims, but then have so many special exceptions to those claims that any reasonable attempt to test the theory's knowledge is effectively eliminated. The second form includes theories that are so vague or overly broad that no relationship can be drawn between a theory's ideas and the real world. Often, theories in this category are able to account for any possible observation, even observations that are contradictory or couldn't possibly both be true. This problem frequently arises when a theory suffers from vague definitions. We're going to talk more about vague definitions later. Related to the idea of testability is the idea of replicability. This means that we should be able to replicate what we find. In other words, we are skeptical of results that have only been observed a few times. If we find, for example, a relationship between crime and age, we really want that relationship to be observable in most data we collect regarding crime and age, not just in one data set. Replicability also means that if you run a test, you should be able to publish your procedures, and other people who run those procedures on the same data should get the same results. Replicability is important because observations can have many causes. If we rely too heavily on one observation, we may fail to understand the actual causal relationship that is responsible for our results. Replicability is also important because much scientific progress happens in conversations between researchers. That means that we need to be able to talk to other people about our ideas. Importantly, we need to be able to talk to people who may not agree with us. Even people who disagree with us should be able to run our tests in good faith and get the same results. We also want scientific knowledge to be refinable. This means that we want to be able to systematically or iteratively improve on our ideas. Occasionally, you'll find thinkers that argue for a take-it-or-leave-it style of theoretical holism. In this case, they insist that all of their ideas must be taken as a package deal because they're meaningless without reference to one another. This view causes problems because it means that a theory could have some good ideas, but wind up losing them in a sea of other ideas that we later find out are wrong. Scientists coming up with wrong ideas actually happens a lot. Scientists are usually wrong. You may be surprised to hear me say that, but a basic fact of research is that many of your ideas are not going to pan out. Unless you're actively involved in a research community, you probably won't hear about all of the wrong ideas that get proposed by scientists. But that's because those ideas are typically exposed to criticism and testing within the scientific community before being shown to the public at large. Scientists want to get rid of the wrong ideas and work with good ideas. But often this process involves a lot of false starts, mistakes, and bad explanations. Imagine what research would be like if we had to take the good with the bad. Imagine if science took an all-or-nothing approach to developing knowledge. We'd never get anything done. Ideas would start out wrong and stay that way. They could never improve. And improving our ideas is the whole reason we want scientific knowledge to be refinable. Relating to the idea of refinement, scientific knowledge should be cumulative. This means that we do not start from scratch each time we have a new idea. We take what was already known and build on top of it. When I say public, what I mean is you do not have to be a special sort of person to have access to scientific knowledge. In principle, that knowledge is open to everyone. That means, in principle, anyone can look at the results of a test, argue about the validity of findings, or develop and refine their own theories. In practice, this really isn't possible. Scientific research typically requires a great deal of training, and it's often so expensive that it requires the financial support of a major institution like a government. So the public for most scientific research is other scientists. But in principle, there's nothing stopping anyone from gaining access to scientific knowledge. What does non-public knowledge look like? Well, that would be knowledge that requires you to be a special sort of person. In other words, that would be knowledge that is assumed to be true because a special sort of person says that it's true. Only other special people can confirm this type of knowledge, and only then in some cases. For instance, some religions teach that spiritual wisdom will fill the hearts of certain special figures within the religion, either especially devoted followers or a special class of priests. You may have heard this idea described as divine inspiration. Or sometimes people will say things like, the Spirit moves me, or I heard God speaking to my spirit. This spiritual wisdom is not public. To gain access to it, you would, according to various religious traditions, need to be chosen by God or some supernatural process. As long as others recognize that you are the chosen one, the knowledge that you have gained is not contestable. As a more common example, you actually have access to quite a bit of non-public knowledge yourself. Practically any subjective, conscious experience you have is not public. Even if you're able to describe your immediate experiences to others, they really can't experience them in the exact same way that you do. They have to take your word for it. Personal, subjective experiences of consciousness are not public, and so the truth of those experiences is really only available to you. I want to point out that I am not arguing that non-public knowledge is unimportant or worthless. The qualia of your subjective consciousness is likely very important to you. How you experience the world doubtlessly influences how you organize and live your life. Likewise, religious knowledge is extremely important to the devotees of religion. This type of knowledge is not public and thus not scientific, but that does not mean that it's not important for those who experience it. Scientific knowledge is representative. What I mean by this is that scientific knowledge is knowledge that represents the empirical world, the world that we can observe, interact, measure, and share experiences about. This might seem obvious, but it is possible to develop knowledge that does not interact with the empirical world. Systems of logic, although they're often useful, don't necessarily need to interact with the empirical world. They're perfectly abstract. And so by themselves, they don't represent anything about the world. Sometimes it's possible to fool ourselves into thinking that we have represented the world when really all we're doing is playing around with sets of rules that we have defined independently of the empirical world. Logic is an essential tool of science, but to say that some set of rules is part of scientific knowledge, we need a way of connecting those rules to the real world. This is often done through testing and measurement, and through the careful definition of important scientific concepts. Finally, scientific knowledge needs to be useful. It can be useful in two very important ways. Scientific knowledge can be used to intervene in the empirical world. By this, I mean that scientific knowledge can be used to change the empirical world in predictable ways. We know, for example, that water boils at 100 degrees Celsius at sea level. This collection of ideas, water, boil, 100 degrees Celsius, sea level, and their relationship, boiling is something that happens to water at a specific temperature and pressure, is useful because it lets us change the world around us. Do you want some water to boil? Well, if you're at sea level, just raise its temperature to 100 degrees Celsius. The other way knowledge can be useful is by allowing us to make novel discoveries. Effectively, we can use what we learn about the world to learn even more about the world. This kind of usefulness is often overlooked or ignored by most people, but it's actually what drives most scientific research. Scientific progress is made on the back of discoveries. So those are some important criteria for scientific knowledge. It should be testable, replicable, refinable, cumulative, public, representative, and useful. So a good scientific theory then will produce knowledge that has these characteristics. Social science theories are explanations of social phenomena that produce scientific knowledge. So far, I have described to you what the point of theory is, to produce scientific knowledge. I've also described what scientific knowledge looks like. It's testable, replicable, refinable, cumulative, public, representative, and useful. To better understand how theories do that, I'd like to turn our attention to the parts of a good theory. Theories produce scientific knowledge by creating theoretical concepts that represent the empirical world and relating those concepts to each other through sets of causal statements. That might not seem like much to you, so let's break down the parts of a theory. Concepts are the terms defined by the theory. It's important to define concepts because without well-defined concepts, we can't test our theory. And remember, testability is something we're looking for. Also, because poorly defined concepts make it difficult to relate one part of a theory to another part. Finally, good definitions are important because they give us a way to relate our concepts to the real world. But theoretical concepts need to be abstract. What that means is that they should not be bound to a particular time or place in history. Well-defined theoretical concepts represent the empirical world, but are more abstract than specific, concrete situations. Abstract concepts allow us to apply our ideas to a wider range of empirical situations, and they let us generalize about a whole host of situations and explain them with a single theory. If we use specific, concrete definitions, then our theory would not be able to explain much about the world. It'd be limited to situations where the specific definition applied. For example, Boy Scout is not a good theoretical concept, because to know what is meant by the words Boy Scout, you need to know something about a particular time and place in history. Any theory that uses Boy Scout as a defined concept would be very limited in scope. It could only apply to an incredibly small range of social phenomena in a very specific time and place. But we could come up with a more abstract definition. Instead of Boy Scout, we could use the idea of group identity, a concept from identity theory. Group identity is defined as a set of meanings that emerge in interactions with specific sets of others. Here, the concept of group identity is abstract. It's not bound in time and space. It's not a specific part of history. Notice that group identity describes the concept of Boy Scout. Boy Scout is a group identity because for any particular member of a Boy Scout troop, what it means to be a Boy Scout will emerge as a consequence of their interaction with others in their group. But the abstract concept of group identity is not limited to kids that like the woods. Concepts like PTA member, book club member, family member, and gang member are all concrete instances of the abstract concept group identity. So you can see how using abstract definitions makes your theory more powerful. Now we can test all sorts of situations that we would not have been able to look at with a much more limited theory. Suppose we want to test a claim made by identity theory. For the sake of argument, let's say that identity theory suggests that the more group identities a person has, the less likely they are to experience depression. Well, we can't really use the idea of group identity to run our test because the idea is too abstract. What we would need to do is find a concrete example of a group identity. Our test would be valid so long as our concrete example fit into the definition of group identity. So, if we want to do a test, we need to come up with a concrete instance of our abstract definition, one that we can actually measure and interact with. In other words, what we need to do is connect our theoretical concept to the real world. Scientists call this process operationalization. I hope by this point you can see why we want good definitions of our theoretical concepts. If our definition of group identity is vague, then it will not be clear that any concrete phenomena meets the definition, and we would not know what to make of our test. Fortunately, the definition of group identity used by identity theory is quite precise. It even gives us a step-by-step guide to follow for determining if a concrete phenomena is a group identity. How do we know that Boy Scout is a group identity? Well, to find out, we can just check the definition. Do Boy Scouts exist as specific sets of people? Yes, Boy Scouts are troops of kids that interact together in an organized program. Do Boy Scout troop members learn what it means to be a Boy Scout as a consequence of interacting with others in their group? Yes, the concept of Boy Scout takes on meaning for a troop member as he, or perhaps in the near future, she, interacts with the scout leader and other kids in the troop. So, following the definition given by identity theory, we can say that Boy Scout is a group identity. That's important because it means that any claim that identity theory makes about group identities now applies to Boy Scouts as well. This is how good theories connect their ideas to the empirical world. Earlier, I spoke about the problems with vague and overly broad definitions in theory. Can you see why this would be a problem? Suppose we want to test our idea. The more group identities a person has, the less likely they are to experience depression. Imagine if, instead of giving us a clear definition of group identity, identity theorists just used the term without defining it. It would be up to us as experimenters to figure out what group identity meant. What if our interpretation of that concept differed from another group of experimenters? What if when we ran our test, we got results that were different from the results of another group? By relying on vague definitions, the theory's ability to produce scientific knowledge would be totally destroyed. We really couldn't test the theory's ideas because the theory's ideas are poorly defined. Our results would not be comparable to the results of other researchers because we wouldn't be working from the same understanding. We could not build off the work of others because we'd never quite know what is meant by group identity. With no reliable way to connect the idea of group identity to the real world, it's doubtful that we are actually representing the real world. And finally, Since we couldn't find agreement on the meaning of group identity, we couldn't use the theory to reliably intervene into the empirical world. Our ideas would not be useful. I hope you can see that good definitions are an important part of a good theory. And when you are evaluating the theories that you're going to learn about in this course, I want you to think about how they're defining their concepts. It's fortunate for us that identity theorists have developed a precise definition for group identity. While good definitions are important, they do not make up a good theory by themselves. For a working theory, you need some way to relate concepts to one another. We do that with theoretical assumptions. Theoretical assumptions link defined concepts to one another. Assumptions are sometimes called axioms, propositions, maxims, principles, or occasionally laws. For clarity, I'm just going to call them assumptions. No matter what they're called, assumptions are statements about how theoretical concepts are related to one another. Legitimacy theory, which you'll learn about in week 3, has among its defined concepts two important ideas: propriety and incompatibility. Propriety is defined as an individual's belief that an authority system is appropriate, that that system is good. Incompatibility describes the extent to which an authority system rewards or punishes a person for things that are actually in that person's control. Incompatible authority systems punish people for things outside their control, while compatible authority systems punish people only for things that are within their control. So we have two defined concepts, propriety and incompatibility. How do they relate to one another? Well, according to the theory, the more that a person believes an authority system is incompatible, the less propriety that system will have for that person. So we say that propriety and incompatibility are inversely related. The greater one is, the less the other will be. This statement, propriety and incompatibility are inversely related, is our theoretical assumption. It relates two defined concepts to one another. I'd like you to notice that the statement is causal. That is, the assumption claims that incompatibility has a causal effect on propriety. This is an important feature of theoretical assumptions. They make causal connections between different defined concepts that the theory uses. Because the theoretical assumption is causal, and because we have two clearly defined concepts, we can test the assumption. We can find out, does incompatibility actually lower propriety? That's what good theories let us do. They let us test things in the real world. The point here is that theoretical assumptions are the tool that theories use to relate defined concepts to one another. So theories have both defined concepts and theoretical assumptions. Concepts are abstract, but their definitions allow them to be related to the empirical world. Theoretical assumptions are causal statements that relate defined concepts to one another. All of the theories you will encounter in this course will consist of multiple assumptions and definitions. Think of a theory like a network. Each spot in the network is a concept, and each concept is linked to other concepts through the theory's assumptions. Explanations given by a theory are really just patterns of theoretical concepts and assumptions. This might seem really abstract, but these patterns of concepts linked together by assumptions can be used to explain some really interesting social phenomena. There are lots of explanations about social phenomena, and most of the explanations of the social world are not thought of as scientific theory. I'll give you an example. There are people who believe that the world's governments are secretly controlled by a powerful race of reptilian aliens. One of the major differences between explanations like lizard people and scientific theories is prediction. The causal relationships described by a theory's assumptions allow you to make predictions about what will happen in a social system. Those predictions can be tested, usually through experimentation. The ability of a theory to produce testable predictions is one of the things that makes it scientific. Really, explanation and prediction are two sides of the same coin. If you understand a social system well enough to explain it, then you should be able to predict what will happen in that system given some set of initial conditions. Prediction is one of the things that makes theoretical knowledge useful. In fact, you will often hear experimentalists and theorists alike refer to the predictive utility of a theory. When the predictive utility of a theory is high, we mean that the theory has made a lot of successful predictions about a social system. When a theory has a lot of successful predictions, it's a good sign that the theory's explanations are actually modeling the real world. Of course, predictions need to be derived from the theory's system of defined concepts and theoretical assumptions. The prediction also needs to be risky. In other words, predictions need to be made in such a way that they can be shown to be wrong. Okay, I have given you a lot about theory in this video. I want to sum up really quick. The point of a theory is to produce scientific knowledge. In other words, the point of a theory is to produce knowledge that is testable, replicable, refinable, cumulative, public, representative, and useful. Theories consist of defined concepts that are related to one another through causal statements, which we call theoretical assumptions. A theory's system of causal statements can be used to explain important social systems, and we can use them to make predictions about the social world. Finally, good theories represent the real world, and they can be tested because they make risky predictions. So I wanted to go over the basics of theory because this class is heavily focused on theory. In the future, you're going to be asked to evaluate theories, and so I want you to be looking out for the things that make theories good and looking out for problems. So what should you look for in a good theory? Well, as you're reading through this course, I'd like you to ask yourself the following questions. Are the concepts in the theory well defined, or are they vague? Are the concepts abstract, or are they bound in time and space? Does the theory make causal statements about the relationship between those concepts? Can those causal statements be tested? Are the predictions made by the theory risky? Or can you make those predictions without the theory's concepts and assumptions? Okay, like I said, I've gone through the trouble of explaining this view of theory to you because in this class, your job will first be to understand and then to evaluate the theories of social psychology. And I wanted to give you the tools to do that. This video is meant to introduce you to this way of thinking about theory. Theories give us answers to the how questions of social psychology. In other words, they explain how processes work or how things get to be the way that they are. As you are working through the material in this class, pay attention to the how questions of each section. When you're looking at the theories, try to answer for yourself. How well do they answer their question? Spend some time thinking about how these theories work, what their concepts are, and how those concepts are related to one another. What sort of predictions can theories make, and how can you test those predictions? Next week, we start our first real look at social psych theories. We're going to be looking at theories in the symbolic interaction framework. So we're going to explore George Mead's ideas about the self and symbolic interaction. We're also going to look at identity theory, which explains how people understand their social selves. And we're going to look at affect control theory, which explains how people understand social situations. As always, if you have any questions about the course's content, feel free to email me. I do want to hear from you. And I'll see you in the next video.